Hello, everybody, and welcome back to Maths. I hope you're having a fantastic day, and we're about to have a fantastic time together doing some review. So in the last video, we discussed how to convert fractions into decimals. We saw that it was pretty much just review of long division. So now's the time to get comfortable with it with these tailor-made problems just for you. So pause the video, try them out yourself, and once you've done that, let's go through them together. Alright, so assuming you've done that, let's give it a shot. Alright, question 1. Convert the following fractions into decimals. So the first one we have is 5/8. And again, we saw that we can think of fractions as division. So 5/8 was the same as 5 divided by 8. So we just need to compute that. So we'll do 5, and then we will put the little division bar here and an 8, and we'll do the division. So 8 can't go into 5, so we put a 0 there. But we can extend the digits that we're working with here by adding a 10th spot, just a 0 there, right? 5 is the same as 5.0. So now we ask, how many times does 8 go into 5.0? Well, 8 times 6 is 48, so that's the highest we're going to be able to go. So we'll put a 6 here. 6 times 8 is 48. So subtracting that, 50 minus 48 is 2. Alright, so then we have a 2, 8 can't go into it, so we'll just do the same trick where we put another 0 in the decimal spot, because again, it doesn't change what the number actually is. Bring it down, and we have 20. How many times does 8 go into 20? Well, it just fits in 2 times, right? Because 2 times 8 is 16, can't fit any more in there, otherwise we're passing 20. So we have 20 minus 16 is 4. So now we do it again, and this should do it, because we're going to have a 40, and 40 is a multiple of 8. 8 times 5 is 40. So we get a 5 here. So 5 times 8 is 40. So we subtract off 40. We have nothing left over. So we've completely covered what 5 is. And so we get that 5/8 is the same as 0.625 as a decimal. All right, let's go on to the next one, 3/10. So 3/10 we can think is 3 divided by 10. So we put that into our division, and we have a 10 here. So 10 can't go into 3, so we'll have to put a decimal 0 here, and we have 0 point. And now we want to look at what number goes here. So how many times can 10 go into 30? Well, it can go in 3 times, right? So 3 times 10 is going to be 30. We subtract that off, we get 0. So we're already done. So 3/10 is just 0.3. All right, that was pretty easy. Next one, 1/9. All right, so 1/9 is the same as 1 divided by 9. 9 can't go into 1, so we put a 0 here, and then we'll put our little decimal so we can expand 1, and we get a 0. So how many times can 9 go into 10? Well, 9 goes into 10 once, right? So we have a 9, and we subtract 9 from the 10, and we get 1. And then we put a 0, we carry it down, and we're at 10 again. Oh, well, I guess 9 can go in there once. Subtract it off, and we get 1. And this is just going to keep on continuing, right? There's no way we're going to actually be able to terminate this. So this is going to be a repeating decimal. So we can say that 1/9 is 0.1 repeating. The 1 just keeps on going forever and ever and ever. So sometimes our fractions are going to be these infinite decimals. Other times they will be finite or they'll terminate. Yeah, so let's go on to the last one here, 10/11. So this is 10 divided by 11. All right, so we'll put a 10 in here. So we're doing 10 divided by 11. So we look at the first digit, which is 1. 11 can't go into 1, so nothing there. 11 can't go into 10 either when we look at both of these, so we still have nothing. So we're going to have to start going into the decimals. So now we're thinking of this 10.0 as like 100. How many times can 11 go into 100? That'd be 9 times, since 9 times 11 is 99. So we subtract off 99 and we get 1. Can't go into 1, so we have to bring in a 0, so we get 10. But just like before, we had the problem where 11 still can't fit into 10, so we have to put a 0 here, and then we have to bring out another 0 and carry it down, so now we're back at 100. Once again, it goes in 9 times to get 99, subtract it off, and we're back to 1. So kind of like 1/9, it's looking like this is going to be an infinite repeating decimal. Right, we're going to have a 0, bring it down, we're at 10. 11 can't go into 10, so we put another 0. So that means we're going to have to take out another 0 in our decimal expansion to get 100. 11 goes into 109 times, get 99, and we're back at 1. So it's just going to keep repeating, right? So what we can say then is this decimal is 0.909 repeating. So this 09 just keeps going on over and over and over again. All right, so that is question 1. And for extra practice, make your own fractions, just like I did here, right? And convert them into decimals. And for those of you familiar with improper fractions, and we're going to cover that in a future video, but if you already know what they are, try some of these with improper fractions as well. You're going to see it works quite smoothly and quite analogously with what we've been doing for these regular fractions. All right, so that's question 1. Let's move on to question 2. All right, convert the following into decimals. What pattern do you notice? This is just like 1 where we're converting these into decimals, but they're all fractions out of 10, right? So I'm trying to see if there's actually a pattern when it comes to fractions out of 10. Let's see if we can figure it out. So we'll start with 2 out of 10. 2 out of 10 is just 2 divided by 10. And we want to see what that is as a decimal. So we'll do 2 divided by 10. 10 can't go into 2, so we have to put a 0 here. And then we'll start expanding 2 because we've run out of digits, so we have to start putting in decimal zeros. So we'll put a 0 here. So 10 goes into 20 2 times. So we have 20 here. We subtract that off, and we get 0. So we're already done because we have a remainder of a 0. So 2 tenths is the same as 0.2. All right, let's go into 7 tenths. So if we do 7 divided by 10, 10 can't go into 7, so we have no choice but to put a 0 here. And then we'll put our decimal because we are now going into the expansion of 7. So 7.0. So now we're thinking of this as 70. How many times can 10 go into 70? It goes in 7 times, but it goes in exactly 7 times, right? Because 70 minus 70 is 0. So now we're done. 7 tenths is 0.7. All right, you might start to be seeing what the pattern is, but let's just keep going here. So we'll look at 9 tenths now. So that's just going to be 9 divided by 10. 10 can't go into 9, so we put our 0. 9 is the same as 9.0. How many times can 10 go into 90? It goes in 9 times, right? 9 times 10 is 90, so we subtract that off, and we get 0. So we get 0.9. And let's do 1/10 just for good measure here. So we have 1. We're dividing it by 10. 10 can't go into 1, so we put a 0. And then we put our decimal here because we're going to have to expand the digits of 1. So we have 1.0. We're thinking of this as 10. How many times can 10 go into 10? It goes in once, exactly once. So we subtract off 10, we get 0. So we're done. 1/10 is 0.1. All right, so what do we notice about these? 2 tenths became 0.2. 7 tenths became 0.7. 9 tenths became 0.9. 1/10 became 0.1. So what it looks like is happening is basically the numerator is kind of involved in our answer where we're just kind of taking a decimal in front of the numerator, right? 2 became 0.2, 7 became 0.7, and so on and so forth. And the reason this kind of happens is because when we're noticing that 10 can't go into this number, we're adding a 0 after it, right? And 10, what does it mean to be a multiple of 10? The number has a 0 at the end of it. So pretty much immediately, our number is going to be a multiple of 10 once we add this extra 0 to it, right? And we're thinking about it as 20. We add an extra 0 here and we're thinking about it as 70. All of these numbers immediately become multiples of 10 because we're looking at this 0 afterwards. So because of that, then the 10 will go evenly into it and it's just going to happen in one step, right? So that's why there wasn't any more decimals because the 10 evenly went into these numbers. So that's just kind of an interesting little pattern with fractions out of 10, and it's maybe something you can notice. So in the future, if you have something like, let's say, 8 tenths, instead of doing long division, you can just kind of remember what the pattern for dividing by 10 is. You just put a 0 point and then put the numerator, right? 0.8. So I think that's kind of an interesting problem. And I have a little challenge for you. Try and see if you can find a pattern for dividing by hundreds. So for fractions out of 100, so like 13 hundredths or 73 hundredths. See if you can figure out a pattern there. Or with thousands, like 502 out of 1,000 or 16 out of 1,000. See if you can start finding patterns that go into these numbers where it's basically tens, hundreds of thousands, and so on. So that's just a little practice for you, and you might find an interesting pattern. We will talk about that in a future video, though, but it's good to explore it for yourself. All right, moving on to question 3. All right, so it says, explain in 3 different ways why half equals 4/8. Alright, so these are equivalent fractions, and we want to explain in 3 different ways why they are equivalent. So one way we can do it is using the method that we saw in a previous video where we discussed how to convert fractions into each other, which was by multiplying the numerator and denominator by the same amount. So if we multiply the numerator here by 4, and we multiply the denominator also by 4, well, 1 times 4 is 4, and 2 times 4 is 8. So we see here that we get an equivalent fraction by using this multiplying by 4 on the numerator and denominator. So that means 1/2 is equal to 4/8. So that is our first method. The next method is just going to be a visual one. So if we consider a pie here and we split it into 2 halves, right, 2 equal portions, then 1/2 is just going to be one of those portions shaded in, right? But if we take the exact same circle and we split it into 8 portions instead and we shade in 4 of those portions, what do we see? Well, we see it's the exact same portion shaded in, right? So because of that, it is the same fraction. 1/2 or 4/8, they're expressing the same portion of the shape that is being shaded in. And the third method of explaining this will be using what we learned in the corresponding lecture video to this exercise. If these are equal, they should have the same decimal as each other, right? So what we're going to do is we're going to do long division for both of these, convert them into a decimal. If it gives us the same decimal, we're going to know that these are equivalent fractions, right? Because they're corresponding to the same number on the number line. All right, so let's start with 1/2. So 1 divided by 2. 2 can't go into 1, so we put a 0 here, and then we will do 1.0, and put a decimal up top here. All right, so 2 goes into 10 5 times, right? 2 times 5 is 10, so we'll subtract off 10, we get 0. So we get that basically 1 divided by 2, or 1/2, equals 0.5. Now let's try 4 divided by 8. So we have 4 here, we're dividing it by 8. 8 can't go into 4, so we'll put a 0 here. And then we're going to put a decimal, and then we're going to add a 0.0. Again, it's the same thing as just 4. How many times can 8 go into 40? It goes in 5 times, and exactly 5 times, right? 8 times 5 is 40, so we'll subtract off 40, and we get 0. So we get that 4/8 is also 0.5. So since they're both 0.5, they have to equal each other, right? So that is another way of showing that 1/2 equals 4/8. So we just did that in 3 different ways. Look at how versatile you are. All right, moving on to number 4. All right, explain in 3 different ways why 8/8 is equal to 1. All right, so the first method is just using equivalent fractions. We've discussed before that when the numerator and denominator are the same as each other, they're equal to 1. We just kind of showed that in a previous video. So since the numerator and denominator are the same, basically we're looking at 8 pieces out of the 8, so that is just equivalent to 1. So we can say since the numerator and denominator are equal. All right, so that's our first way of explaining it. The second way we can do visually, right? So we'll take a circle here, we're going to split up into 8 pieces. All right, so we've split up in 8 pieces, and if we shade in all 8 of those pieces, surprise, surprise, the whole circle is filled in, right? So that's another reason why 8/8 is just 1. And it doesn't just have to be with a circle, you could do this with other shapes as long as the pieces are the same size. So I split this into 8 pieces, shade it all in, and the whole rectangle has been shaded in, so 8/8 equals 1. All right, and the third method we saw was doing division. So 8/8 is the same as 8 divided by 8. We don't even have to do long division for this, because what's a number divided by itself? It's just 1, right? If I have 8 things and I want to share them amongst 8 friends, they each only get 1 thing, right? So 8/8 is the same as 1. All right, and the last question here, this one's a little bit of a review, because it's always good to go back and review things in math to make sure you're still remembering them and staying strong with the topics, because one way or another, it's going to come back at some point. For this review problem, we want to find all the factors of 99 using its prime factorization, and this was from the Fundamentals of Algebra number 13. So the way we did this is we first prime factorized the number, and then we found all of the combinations of those prime factors, which will then give us all the factors of 99. So let's start with the prime factorization. 99, that can be split up into 9 times 11. 11 is prime, so we're good there. But 9 can be split up further into 3 times 3, both of which are prime. So that means 99's prime factorization is going to be 3 times 3 times 11. All right, so now that we have that, we just can get all the factors of 99. So we know that 1 is always going to be a factor. That won't be covered by the prime factorization because 1 isn't a prime number, but every other factor will be. So now that we've covered 1, we can look at the combinations of factors. So we have 3, so we can look at 3. Then we'll have 3 times 3, so that's 9. So 9 is going to be a factor of 99. Then we can do just 11 by itself, so that'll be 11. But then we can start combining a 3 and the 11. 3 times 11 is 33, so that means 33 is going to be a factor. And then the last combination is just all 3 of them together. So 3 times 3 times 11 is 99. So these will be all of our factors of 99 because this is 1 and then all the combinations of these 3 different prime factors. Alright, so I hope you found that video useful and I hope you're feeling a little more comfortable with these concepts now. So keep up the good work and keep up the practice. And as always, have a good one, stay groovy, I'll see you in that next video.